Hi, my name is Bob, and I approve this message.
I got the magic in me. Every time I touch that track, it turns into gold. Everybody knows I got the magic in me.
The purpose of this lab is to measure the transfer of energy between water and wax of the candle.
In doing this, we are going to help you understand the concepts of heat combustion and the molar heat of combustion, which also means the amount of energy released in the reaction and how much energy it took to allow that.
Measure the mass of the candle. It is 12.18 grams.
Measure the milliliters of the chilled water. It is 74.1 milliliters.
Set up the apparatus that will help us determine the heat of combustion.
Pour the 74.1 milliliters of chilled water into an empty soft drink can.
Then we measure the temperature of the water using a thermometer, finding it to be 8.1 degrees Celsius.
Then we place the candle under the can of water. We lit the candle, heating the water.
We waited until the temperature rose 20 degrees Celsius, making it 28.9 degrees Celsius. Then we measured the candle again to see how the mass of the candle had changed. The mass changed to 11.98 grams.
Now we will walk you through the data analysis of the lab,
in order for you to calculate the heat of combustion successfully. Number 1. Calculate the mass of water heated. Remember, the density of liquid water is 1.0 grams per milliliter.
To calculate this, we must know that our water volume is 74.1 milliliters. We put that over 1 and then multiply it by 1 gram over 1 milliliter to get 74.1 grams of water.
Number 2. Calculate the total rise in temperature of the water in degrees Celsius.
To do this, we take our final temperature of 28.9 degrees Celsius and subtract 8.1 degrees Celsius to get 20.8 degrees Celsius.
Number 3. Calculate how much thermal energy was used to heat the water sample. In order to do this, use values from the 2 preceding steps to reason out the answer.
Here we are calculating the energy absorbed by the water and released by the candle. The specific heat capacity of water is 4.18 joules over 1 gram times 1 degree Celsius. We take that and multiply it by our mass of water, which is 74.1 grams over 1, and then multiply it by our change in temperature, which is 20.8 degrees Celsius over 1. That equals 6,440 joules of energy.
Number 4. Calculate the total mass of paraffin wax burned.
To do this, we take the initial mass of the candle, which was 12.18 grams, and subtract 11.98 grams, which was our remaining mass, which equals 0.20 grams of wax, which is how much was burned.
Number 5. Calculate the heat of combustion of paraffin expressed in units of joules per gram of paraffin.
To do this, you take 6,440 joules, which is our energy, and put it over 0.20 grams of wax, which is the total mass of wax burned, which equals 32,000 joules per gram. This is the heat of combustion.
The heat of combustion is usually expressed in units of kilojoules per gram. So now we need to convert this to kilojoules.
For 1 kilojoule, there is 1,000 joules. So we take our heat of combustion and multiply it by 1 kilojoule over 1,000 joules to get 32 kilojoules per gram.
Number 6. Now we are calculating the molar heat of combustion expressed in units of kilojoules per mole.
1 mole of paraffin has a mass of 352 grams. With this, we can now calculate the molar heat of combustion. Now we take our heat of combustion in kilojoules per gram and multiply it by 352 grams over 1 mole, which equals 11,000 kilojoules per mole. Through these procedures, we determined a variety of things: the mass of water heated, the total rise in temperature, how much the thermal energy was used to heat the water, the total mass of the paraffin wax burned, the heat of combustion, and lastly, the molar heat of combustion.
The thermal energy used to heat the water was 6,440 joules.
The heat of combustion of paraffin from the candle was 30,000 joules per gram paraffin. We converted the joules per gram to kilojoules per gram and got 30 kilojoules per gram. The molar heat of combustion of paraffin was 10,000 kilojoules per mole. Using these results, we concluded that propane would be the better fuel because it has a higher heat of combustion when measuring in grams. This is more realistic than measuring this in moles.
It is also important to note that the heat of the candle could have been released into the air in other directions, not only to the direction of the can. This could have affected our results and could be seen as an uncertainty. We learned how to calculate the release and absorption of energy and learn how to convert them from joules per gram to kilojoules per gram and to kilojoules per mole.
Wait! What did you learn?
When I hit the floor, the girls come snapping at me. Now everybody wants a blast of magic, 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 magic.